Hello, this is Nas from NV Network Lessons. Good evening. Hope everyone's doing okay. Welcome. This is going to be physics lesson number 6, and we are going to discuss average speed versus average velocity. I'm going to try to explain you that though both of them are really close to each other, but they're not exactly same. But before I start, I just would like to crack a joke, tell you guys a joke about myself. So as an immigrant, I landed in Alabama, Mobile, Alabama in 1985 to go to school. So I was really excited and, ready to pumped up and ready to start the college. So now my background is mostly, I've been going to British schools, all right? So basically what we, people from where I come from, have background in British English. So I come to US and I think it was my third or fourth day and I registered for classes and I was really excited. So I go to the bookstore and I buy some books and everything. And then I was looking for a rubber. And then I just looked around and I couldn't find it. So I go to the desk, checkout desk. There was old lady, I would say probably close to 80 years old, had glasses on, white hair. I said, hello, I'm looking for a rubber. And she looked at me funny. And people behind me were kind of smiling. So I couldn't figure it out. What's going on? I said, ma'am, I just need a rubber. I've already got pencils and books and everything. I need rubber. She looked at me and she said, what do you need rubber for? You guys, you came over here for education. You go to school and then what do you need rubber for? Just study, concentrate on studying. And I'm like, what the heck is she talking about? So then I see a rubber behind the counter, which is called a razor in United States. And I said, ma'am, that's it. It's right behind you. And I pointed it. And she picked it up and she said, this is a razor, not a rubber. And then everybody started laughing. So I thought that was funny. Kind of wanted to share that with you. But anyways, let's get into average speed and average velocity. In my last lecture, I explained you distance versus displacement. And I explained to you that distance and displacement are really close, but they're not the same. Why? Because distance only has a magnitude, does not have any direction. Displacement has direction as well as magnitude. So this is a vector. Now we're going to talk about average speed versus average velocity. Now let me ask you this. When you're driving in a car, and you're looking at your speedometer, you're just basically looking at if you're going 40 miles per hour, if you're going 50 miles per hour, you want to make sure that you're not breaking the speed zones. So you kind of keep an eye. But do you keep a track of direction? No, nobody keeps track of direction, right? When you're driving, you know where you're going to go. You know the roads, you know the point A, point B. So average speed is what you see on your speedometer, okay? Now we come to average velocity. So let me go over an example. Average speed is going to be always positive. So let me draw this one-dimensional x-axis graph. Let's say this is 0, our reference point, okay? And we have 1, 2, 3, okay? And then I have -1, -2, -3, okay? And I tell you that my initial point, where I am right now, is going to be -2. And my final point is going to be 2. So how much distance I have traveled, okay? So the way you find out is that D is equal to XF minus XI, right? Which is equal to Fx is 2 minus, be careful over here, you got to put this -2 in brackets, because this is negative. So that's 4. So basically, my average distance which I've covered is basically 4, which is positive, right? Which is positive. So now my question to you is that I know how much distance I've covered, all right? But how do I know what direction I'm going? Am I going in the right? Am I going in the left? Okay, so that is what average velocity does. The average velocity has a magnitude also, and it has direction also. Just like displacement, displacement has magnitude as well as direction. Average velocity does that too, and I'll show you that in just a second. So then we look at the average speed. Okay, average speed is basically what? Distance over time. Distance over time. So in this particular case, I can say distance covered is 4 and the time is seconds. So I would say 4 over 1. So it's 4 meters per second. Easy peasy. All right. Now let's look at average velocity. Average velocity, really interesting, analysis. Whoever did this, average velocity is basically displacement over time interval. Okay. Now time interval. So displacement, as you already know, can be positive, can be negative. Okay. So, but time cannot be negative in terms of physics. Well, if you get down to physics 3 and get into like very high level physics, yes, but not at this stage. So you have average, let's find average velocity. Average velocity is basically displacement over time interval. Displacement, I showed you in my last lecture, is delta x, change. Okay, what is the change? Okay, and then time interval is basically tf minus ti. Okay, let's say you're right here. Okay, at 1, this is your ti. That means that is your home, that is your school or whatever. You are sitting over here and you're traveling, okay, and it took you 2 seconds to get to your school, so that is delta t. Make sense? Okay. So then I can say average velocity is delta x, all right, change in distance, which is displacement, over tf minus ti, which is the time interval. Now let's look at an example real quick, and then I will close the session and I'll come back. So if you look at it, example, let's say you have one-dimensional motion. This is your x at 0 origin, all right? You've got 1, you've got 2, all right? And then you got 1, 2, 3, 4, and this is negative 4, okay? And this is your reference point. Okay, so xi, initial position where you are, is given as 4 meters. So you are actually negative 4 meters. So you are sitting right here. This is your xi. Your starting point is this, all right? And then I tell you that your final point is 2 meters, which is right here. So this is my x of f, all right? Now, what is going to be my average velocity? Okay, so average velocity is going to be delta x over delta t, which is equal to xf minus xi over tf minus ti. Okay, so in this particular case, we said that the time it took for you to get from this point to this point is 3 seconds. So time interval is 3 seconds. Okay, so then fx is 2, final 2 minus, again, watch out, this is a -4. So you got to put -4 in brackets, otherwise it will mess up your answer. And then the time interval is already given 3 seconds. So then what I have is that 2 minus this becomes 6 over 3. And then this is basically 2 meters per second. All right. So if this is point A, this is point B, okay, and you're going from point A to point B, your average velocity is 2 meters per second. This is average. Now I'm going to introduce you a concept of instantaneous velocity. See, if it takes me 3 seconds from point A to point B, I'm going like this, right? So that's 3 seconds. What if I want to measure the velocity at a certain instance? Let's say I'm going at, it takes me 5 seconds to get from point A to point B. I go very fast, right? Took me about, 2 seconds right here. Then I slow down. So that is instantaneous velocity. So we're going to get into that also. All right. Hope you enjoyed it. Hope you enjoyed my little joke also. Send me in my comments if you like for me to crack more jokes like that. Thank you so much for watching. Take care of yourself. And if you like the contents, please share and give me a like. Thank you.